backend engineer here for a bit over a year now. Could you just tell me a bit about yourself and we can jump right into it? Cool. Send you a link right now. I'll say this is a pretty standard coding interview question. You will have 30 or 35 minutes to do it, and we will leave the last 5 to 10 for any Q&A, any questions you have for me. You will notice that this is just an online text editor because I'm not looking to actually run your code here. I'm more interested in how you will approach your problem and design a solution, so you don't necessarily have to worry about writing something that has to be syntactically perfect.
So given a string S, partition S such that every substring of the partition is a palindrome. Return all possible palindrome P. Palindrome string that reads the same backwards forwards. Okay, so you're given a string AAB, and you're trying to see all the possible palindromes of that string. Okay, so I guess can I assume the input is always valid?
Yes, you can assume the input is always a non-empty string. And the lectures here say all possible palindromes. The question actually asks for all possible ways that you can partition the strings such that the condition is satisfied.
Okay, yeah, all possible ways to partition it. Okay. All right, so ways to partition a string. So if I have some string, I can split it out in this way, split it out to that way, different ways to split it out. So I guess first off, I'd want to write some helper function that checks if something is a palindrome, because I imagine if I generate different partitions, I want to be able to quickly check if this partition is a palindrome. So if you have some substring, is that a palindrome? So I'm going to have some helper function to do that. But for the main part, I can imagine the space of possible palindrome or partitions. Let me think. Well, we know that essentially with a palindrome, the middle, then the end, so it reads the same at the front, it reads the same from behind. So we know that, let me think. Let me think. So imagine, do you have an expectation on the time complexity that I should aim for?
Let's say we can start with the brute force and we can tell about how we want to optimize it. So,
because I imagine, here, let me see. I feel like DFS might be helpful here. How would if I start here and explore these, how would that work? Yeah, I can imagine a case so I check if something's a palindrome, and if it is, I have some DFS function, and I could, how would that work? Sounds tricky. All right, so let me think. All right, so if I generate all possible substrings, and I start with some start index, and I have some end index where I'm going to increment from start till end. And all right, so if I have some start index and I have some end index that increments from the start, and I'm going to increment all the way to the end, I'm going to want to generate substrings using start and end index. For each substring, I need to check if it's a palindrome itself. And if the substring is a palindrome, then it might be one of the partitions. So if I take that substring, which might be a palindrome, and if I run DFS on the substring, or the remaining part of the substring, that might work. All right, so if I generate all the possible substrings, and I increment the end index from start till end, and I'm going to have my helper is palindrome function, I can run that on each substring. And if that passes, then I can just take the substring and I can put that substring somewhere else, some list, and then run DFS on the remaining part of the substring. And if the end index for the current substring, that would be the start index for the next call in DFS. I think so. Yeah, if I do this, put that there, put this, the next index will be the current call of the DFS. And then would I need to backtrack here? I hate these palindrome questions.
I'm sorry.
Anyways, yeah, so I think backtrack might be useful. All right, so a helper function to check if it's a palindrome, generate substrings, start pointer, end pointer for the index, DFS, possibly backtrack. I feel like those are the important parts. Let me write those down so I don't forget them.
Of course.
So I know I'm not going to run this, but I'll just put comments just for habit. So one is palindrome helper function. Then I want generate all possible substrings I'm gonna have initialize, start, and end pointers. Then check if substring based on start index and end index is palindrome. If that's a palindrome, I want to add that substring to separate list. Then after do that, I'm going to run DFS on, I take that part, it's on the end, and then the rest part, I want to run DFS on to run on other part of existing substring. And let me put a optional. I'm not sure yet if I'll need to backtrack, so I'll just put optional for now. So backtrack. Yeah, if the start is not greater than the length of the whole string, then I would have to backtrack to go back in. I think so, but this is optional. So backtrack if start index is greater than, let me say, length of string. There might be edge cases here, but how does that look? Does that look reasonable?
Yeah, I think you are definitely on the right track.
Okay. Would you want me to try and implement this first, or you think of something more optimal?
Yeah, I think we're good to implement this first.
Okay.
And we'll discuss optimization near the end. That's totally fine.
Okay, that sounds good. And this is fairly language agnostic. I just write pseudocode. Okay. So I guess we'll have some. Like I said, we'll have some partition class. I'll just use a Python-like pseudocode since Python is fairly easy to some string s, and even we're gonna have some partition string, and I'm also gonna have some is palindrome. Again, that takes in some string. And palindrome is pretty straightforward because I think in Python I can just do a list slice. So I can just say if the front of the string is equal to everything in the reverse of the string. So this is fairly easy to do in Python. So I say return.
That's the interview language.
Yeah, exactly. I think that S is equal to just the reverse, which is, I think, everything at the beginning, everything at the end, and then one to the back. Yeah, that should be good. So now here, so let me say, well, my return palindrome reads return all possible palindrome partitions. So we say palindrome partitions equals to this. I'm gonna want to return that at the end. All right, so how do I want to do this? I have the helper function, and I want to generate all possible substrings. So I'm going to need some DFS function in here to define DFS. Let me say, as for now, what do I want in my DFS? So as I go through the string, I'm going to need some start index. So int start index. I'm going to need the string. What else do I need? I need to be able to keep track of the list of strings so far. I'm going to have some list, and it's going to be partitions. Okay, what else do I need? I'll add more things if anything comes to mind. But in the beginning, I'm going to want to run my DFS. The start index is 0. That's where you always start. And I'm going to want to put in my palindromes partitions. That's my list. And I'm going to want the string s. I put in the palindrome partitions. Okay. And then inside my BFS, what do I want to do? All right, so the start index, since I'm recursing through, I want to make sure I don't go beyond the size of this. Let me add for so 4. So what do I say up here? Initialize, start. Okay, so I'm going to need an end pointer. So if I say 4, I'll say end in range. And in range, I'll start at start all the way up to the size of the string. It's the size of the string. So for that, I go from end, start index. Let me start index. So start all the way to the end. And what do I say? Initialize start endpoint, and then check if substring based on start index. Okay, so I have to check if the substring is a palindrome. So if is palindrome, and I want to take the substring, so that should just be s, and I think it's start index up to end. Let me just make this end index to make it more consistent. So if that substring is a palindrome, I want to add that substring to separate list. Okay, so add the substring to separate list. Oh, right. I am missing something, so I do need a separate list, so I can keep track of that. So I'll just pass in an empty list, and then here I'll name that separate. Whatever. Not the best with names. Separate list. And what do I want to do with that separate list? So I want to take add that substring. The substring is what I put here. So let me just define that as a separate variable. So substring equals to simple equals to that substring, and then I check if this possible palindrome is palindrome. And if it is a palindrome, then I can just append. Do you want that? Yeah, let me try that. Yeah, so I take that, append that palindrome to a separate list, and then go back to what I was saying. Yeah, I think that's right. And then I can just run DFS in the other part of the substring. So if I say now I just run DFS again, and the start index is now we're all the way to the end. So we want to say it'd be end index now as a start because I got everything up to that palindrome or possible palindrome. And then I can pass in my partitions again, and I'll have to add to the partition soon once that checks out. And then I still have my separate list because that's the one that I just added to that I'm keeping track of. And finally, my string again, so I can continue going through it. So for end index, I start at start index, I'm going all the way to the end. And then I take the substring of the start all the way to the end. And then I check if that substring is a palindrome. And if it's a palindrome, I append it to the list. Then I run DFS on the other half. Yeah, that looks good. When do I add to my partitions? I add to my partitions when it's actually, actually meets the case. So it's a palindrome and it fits all the needs that I'm looking for. So in that case, it would be when I go through the whole list and I keep incrementing the index, and now I'm at the end. So if I'm at the end, that means that whole loop went through successfully. So I want to check at the start of my DFS so I don't run it again. I can just say if my start index is greater than or equal to the whole size of the string, length of s. So if now I'm at the end, then that means everything checked out. And no changes along the way, so I can just add that partitions that append everything that I've seen in the list so far. So that would be separate lists. Let me see. So if I can walk through this. So if I have, let me take this. So I have A, and then that would give me A, separate down to AB. I'm gonna run that on that. That would check out. Yeah, I think I generate the substrings from those. Okay, so that should be good. Let me see if I'm missing anything. So I have that DFS, because I would just return the palindrome partitions and I pass that into my DFS. So DFS would be modifying that along each call stack. Am I forgetting anything else? There's the optional part. I said backtracking is greater than that, but I don't need to, because that doesn't make sense. If I'm at the end, then everything checked out. So would I need to, if I DFS the next one, I think I see where I have to backtrack. I'd have to remove. Yeah. This wasn't worded correctly. Let me just say backtrack. Because at the end, if I add to my current list, and then I run DFS on everything else, then I'd have to remove the last thing that I added. Yeah. So I would. Is it separate list? Yeah, because I just added. That's right. So append to separate list, put it into DFS, then remove from it, so I don't have any issues when that's a backtrack. So. And I don't know if it's delete or remove in Python. I forget which one, but the pseudocode. So, and then we just get what's at the end, which is just get last element.
One small question. I know this is pseudocode, but does this create an issue if we have duplicates in the list?
Yeah, I guess in the case of duplicates, I could just use a set to remove duplicates.
But we do want orders here, right?
Yeah. Or does the order matter of the output?
Yeah, it kind of matters.
Okay.
I think you can always just remove the last index. This I've been nitpicking. This pseudocode.
Yeah.
Yeah, cool. I'm convinced this definitely works.
Okay.
Cool. Why don't we do some runtime analysis and then we can talk about optimization.
All right.
We'll just say it's the worst case runtime here.
All right, sounds good. So let me go through. Let's say n is equals to size of s, which is a string, and let me think. So this palindrome function that would take everything at the beginning and just compare to everything at the end. This should be O of n. It's just checking everything inside the string. Worst case scenario, and then let me see. The DFS function it's always tricky to analyze. So let me think. So if I have AB, let me sort of try and write this out. If I have AB, this can be split off into A, AA. Actually, let me do it this way. So A can be AA and then A, and also AB, AAB, AAB. Then I do this, and then I do, I think it's AAB, 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 yeah, then that's like JSON split up into. And then from there, if I try to go to another level, from here, I can have A, have A, and have B, and have A. Let me move this over because this is starting from the one at the top. Let me try and match them up. Yeah. So if I have this goes to the left, and that will give me A, B, and then over here give me A. Yeah, because an empty string case, so it'd be A, B, and then sort of this empty at the end. But that's not the base case in the recursion. Okay, so I guess at each stage, if I keep splitting out like this, if I remember correctly, if you have this sort of tree structure where you have some root and you sort of have all these branches down, if let's say there are n nodes, yeah, so instead of n size of, let me say n is number of nodes. Or not number of nodes, let's say it's more the height of the tree.
And wherein is the height?
Yeah, let me think. How do I want to define n? Actually, no, what I had was fine. N is the length of the string. Yeah, size of s. That's good. So if I take that s and I split it out, I'm pretty sure this is 2 to the power of n, this whole branching.
That is correct.
Yeah. So this whole thing, so basically this DFS would typically be of 2n, but I also have my 2n for just doing all that branching, but I also have my is palindrome function, which takes O of n, so it'd be times that. So it'd be 2 to the n times n.
Perfect.
Yeah.
You have no idea how many people will just confidently look at this code and say it's n square.
Yeah, it's tricky when you get to the 12, but I realize how quickly that it could explode if you really like separate it out.
And we can leave everything out all the time left for Q&As.
Okay. So how to optimize? Well, can't do anything about the is palindrome function. There's no way to optimize that. So that n is going to stay. So the main optimization has to be in the DFS function. So what can I do here? What are some ways to optimize strings, backtracking, DFS? I'll just going back to what I was saying here. So I have these A's, these B's, these A's, B's, and it sort of goes to something you said before about duplicates. So in the case, not exactly for duplicates for the output, but for the branching, if we end up having duplicate, if you have in one side of the tree, for example, some AAB, everything below that AAB should be the same if some other part of the tree has an AAB.
Yep.
So in that case, how can I reuse that? Probably, is it memoization? Is what I want to do here. And so if I'm going to memoize, I'd have to use DP then. I really hate dynamic programming, but I think that's the best way to address this. Yeah, I think, let me sort of run down my thoughts. So possible optimization. So memoize, DP. How would that work? So if I have this in my DFS, because at each level to DFS, I need to keep track of what's been seen already, and that's why I would have some memo. So I would create some, I'd create some memo inside up here. So it's a memo is equal to, and be the whole size. So it would be, can probably do some list comprehension. It's just an empty list for the X in range, the size of the S. Would that give me, essentially I want a 2D grid that would just represent the whole DP space. I think I can just do that with some list comprehension. So yeah, because the base list comprehension gives me the list, and then the inner list comprehension would give me this empty list for each position. So that should be, but since I can't run to verify, let's just say I create some 2D matrix memo. And then from there, I want to pass that into my DFS function. Let me say. Make it it'd be some bool in each case, a bool. And again, I know this is not Python, but this is just to sort of illustrate what it would look like. So here's some bool, and it has some memo, and
And I guess since it's Boolean, what are we storing here? Are we just storing if this index has a palindrome?
Yeah.
Got it.
And then in that case, I would just take that DP for the memo, and I would say for the start index and the end index, if we've already verified. I guess tricky. I don't know if I can directly just plug this into my DFS. I'd probably have to change some things.
Yeah, that's kind of why I'm more inclined to just talk about it. Don't worry about changing the code.
Okay. Yeah. So in this case, I'd have to modify my original solution. Instead of doing a typical DFS. I would have to do a proper dynamic programming solution where I have a memo. It's a 2D grid. And in each case of the grid, I would want to update it based on what's already been seen. So I would take the start index and the end index, which is what I'm currently passing into my DFS, and I would set that to true in cases where that substring is a palindrome, and it basically gets to the nested part of my DFS function. But I would have to check some more things, like making sure that the character at the start of the string is equal to the end of the string, make sure I don't exceed the indexes, and also with the DP, check if it's already in a previously seen part of the string before I update the later part. I think that's what I want to do.
So, quick question. So, we're storing if this particular subtracking every time if there's something as a palindrome.
Exactly. So that's the part where I'd take out because.
Got it.
I don't know. I can't say confidently if this would. I don't think it would improve the time complexity beyond 2 to the end, because I would still have that exploding case in the worst case scenario where everything is like unique, for example. But it would be an optimization.
I agree. Cool. Yeah, that's kind of all I have for you.
Awesome. I'm glad I didn't have to implement that because I hate DP so much.
So it really depends on how your initial implementation is.
Yeah.
So let's say there's actually, you can kind of optimize for the exploding case. So you kind of pointed out already. So basically, we kind of have this recurring subproblem. So when you call A, comma A and then B, it is the same as if you call you pick AA first and then you call it on B. So basically you are calling on B twice. In this example case, it's a little bit trivial because the B is just is already at the bottom level, but if the string to be a bit longer, you can actually save a lot of runtime if just before you I guess there's an invisible return here. Let's say there is. Before you return here, you just stored separate stores partitions inside dynamic programming dictionary. And next time you see the same index being called, you can just return that dictionary. So that's kind of how you will optimize for the exploding case. But back to my point. The point is that if you're not already returning here, it is kind of difficult for you to basically have to restructure your entire code for this small partition. And that's typically why I just ask people to talk about it rather than implement it.
Yeah. Okay.
Cool. So we have a solid 10 minutes left. Why don't we do a lot of potential self-growth here? And I feel like, I definitely got that part. The third reason is kind of minor. I kind of like San Francisco. I also kind of like Bay Area. Feel like this is the heart of the industry. So I want to see San Francisco.
Okay, nice. And what does the tech stack look like?
Yep. So most team here uses Node or some kind of variation of Node. So Node.js, TypeScript, FlowScript. If you're on the machine learning team, you'll be writing Python. That's kind of given. For database, we use Postgres. For internal message passing, we have RabbitMQ. On our team specifically, our team deals with a lot of image data and media. So we use kind of these image processing library. We have Sharp, image matrix, graphics matrix. For videos, there's FFmpeg.
Okay, so I imagine for the image matching, some of that might be for like data labeling. and such?
Yep. My team kind of deal with data labeling a lot. We generate renders, usually for internal auditing purpose. Sometimes we also show it to client, or sometimes we sell it to clients.
Okay. So I guess I'd be curious to know, how do the products and services offered by compare with all the competitive, let's say, Scale AI? Compare?
Great question, man. I am so prepared for this one.
Yeah.
So the more official response is that we kind of see ourselves less as a data labeling company, more as a machine learning company. So Scale only does data labeling.
Yeah.
And their stuff, I think, don't quote me on this, but as far as I know, all of their stuff is kind of in-house. So they have their own teams, own hire employees. They might not be located in the US, but it's always someone in-house that do the actual data labeling. Cool, great. In that case, you have a good day.